Hey everyone, welcome to my channel. Here are the hardest questions you might see in your geometry class. Finding unknown lengths, solve for h. Now, with this type of question, the first thing that you might be inclined to do is to solve for one of these other little sides. But remember, when we're working with shapes like quadrilaterals, triangles, things like these, we can always just find the areas. So right now, if we were to redraw this parallelogram on its other side, it would look like this, with a base of 36 and a height of 24. So the area of this parallelogram is 36 times 24. Now I'm not going to go ahead and simplify that just yet because I know I'll be able to simplify later on when I solve for the other area here that we see. And that area is the base 27 times the height of h. So these two areas must be equal to one another. So we'll have 27h is equal to 36 times 24. Now 27, when we divide both sides by 27, I can divide by 9 times 3. And notice that 36 cancels out with 9, leaves us a 4. 24 divided by 3 is 8. So my height is just 4 times 8, which is 32. Work smarter, not harder. Now, coordinate geometry is where many students tend to struggle. So I chose to put this into this hardest questions in geometry. Let's check this one out. Excuse me. We have point A is 1, 2. So on a graph, 1, 2 would be right around here. 7, 4 would be 1, 2, 3, 4, 5, 6, 7, 4 right there. And then 5, negative 2 will be right around here. So if we connected these points to the best of our ability, we create this triangle. This is A, this is B, and this is C. Now I want to find the length, the altitude of the triangle from vertex A to B. So when we're talking about altitude of a triangle, this height must create a right angle with the side or the line segment BC. In order to do this, I'm first going to find the equation of the line BC, and then I'm going to create an equation of a line for the line connecting vertex A to this new point, let's call D. Then I'll find the point of intersection, and from that point, I'm going to find the distance between A and D. So step 1, find the equation of line BC. The 2 points B and C are 7, 4 and 5, negative 2. Find the slope. That'll be 4 minus negative 2 all over 7 minus 5. That just gives us 6 over 2, and that's 3. Pretty simple. And now we can use point slope form to say y minus 4 is equal to 3 times x minus 7. I was saying 4 and then, or I just said 4, so I wrote down the 4. So now I have y is equal to 3x minus 21 plus a 4 will give us minus 17. Now, step 2, find the equation of the line between A and D. But first, we have to find this equation. That equation will be the slope that's perpendicular to this original line of BC because they create a right angle. So I have a slope of negative 1/3. From here, I can use the point A, 1, 2, and use point slope form once again. Y minus 2 is equal to negative 1/3 times x minus 1. This will give us negative 1/3 x plus a third plus a 2. So that gives us negative 1/3 x. 2 can be rewritten as 6 over 3. When we add these up, we get 7 over 3. Now, step 3, we're going to set these two linear equations equal to one another to find our point D, the point of intersection. So I go 3x minus 17 is equal to negative 1/3 x plus 7 over 3. The easiest way to do this is to multiply everything out by 3 to get rid of those denominators. So now I have 9x minus 51 is equal to negative x plus 7. Let's move everything to each side, combine like terms. We get something like this. X is going to equal 58 over 10, which simplifies to 29 over 5. Now that we know x, we can also solve for y by plugging it into our very first equation. So we have y is equal to 3 times 29 over 5 minus 17. So 17 we're going to rewrite with a denominator of 5. That will be 85 over 5. Now 3 times 29 is 60 plus 27, so 87 over 5. Well, that just works out to 2 over 5. So that's really simple. Now our fourth step then will be to find the distance between A and D. A is 1 comma 2, and D is 29 over 5, comma 2 over 5. 29 over 5, comma 2 over 5. Let me lengthen that division bar a little bit. And I use the distance formula. The distance formula, D, is going to equal the differences between the x values squared plus the differences between the y values squared and the square root of all of that. So I'll go the difference between 29 over 5 and 1. 1 can be rewritten as 5 over 5. 2 can be rewritten as 10 over 5. So we're finding the differences between these. 29 and 5 have a difference of 24, still over 5. 10 and 2 have a difference of 8, still over 5. Now let's square them. 24 squared, ooh, that's going to give us, let's do that out. 24 times 24 is the same as 24 times 20, which is 480, and then 24 times 4, which is 96. So we have 576. For some reason, that looks off. Let's check our work. 24 times 24 is 12 times 2 times 12 times 2. 12 times 12 is 144, and I'm going to multiply that by 4. So that'll be 400 plus 160 plus 16. So that's 576. Okay, that's correct. So we have 576 plus 8 squared is 64, all over 5, still taking the square root. And now when we add these up, I get 640 over 5. And now 640, that's actually a really nice number because 640 is 64 times 10. You just had a brain fart there. But 64 times 10 will give us the square root of 64 is 8. And then we are left with 10 over 5. So we just have 8 radical 2. And that's it for this problem. Now, on to similarity. In the figure below, segment CE is the diameter of the circle and has a length of 150. Noted. Segment CE is perpendicular to segment AB at point D. All right, all these create right angles then. And BD is equal to radical 296. And we know that CD to DE is equal to K. We want to solve for K. Okay, so we have 3 similar triangles here, if you can see. We have this really big one, CEB. And then we have CDB, the smallest one. And then the middle one, BDE as well. So I'm going to redraw BDE. BDE. I'm going to redraw the small one as well. And the reason I do these, why I redraw the smaller ones, is because I recognize CD and DE as the ones that we're looking at for K. Here's CD and here's DE. That's how I know I have to be using these 2 smaller triangles and not this bigger one. Now, I know that the full length of CE is 150. So if I say, let's say like CD is X, then that means DE must be 150 minus X, because when you add them together, you should be getting that 150. Now, I also know BD is the square root of 296. Now, let's think about what else we know. Oh, check this out. BD is radical 296. DB then is also radical 296. And that's how we come up with our equation. Here's the proportion. Radical, or X, is to radical 296 as radical 296 is to 150 minus X. Now we're going to cross multiply here. We have X times 150 minus X, and we'll have radical 296 times radical 296. This gives us 296 on the right, and this gives us 150x minus x squared. Now, this is a quadratic equation. We can use factoring here. Move everything to one side. This negative x squared becomes a positive x squared minus 150x plus the 296. And in order to factor, this actually factors really nicely into negative 148 times the negative 2 is positive 296, and they add up to 150. Great. So x is equal to 2, x is equal to 2, meaning that 150 minus x is equal to 148. So we wanted to know the ratio K is CD to DE. All right, well, CD is 2, DE is 148. Looks like this simplifies, so we have 1 over 74, and that's the value of K. Some trigonometry to end this one. The following diagram is not drawn to scale. Find the value of x. The easiest way to go about this would be to use the law of cosines. I'm going to show you a little trick in a little bit. You may notice it right off the bat as well, but I'm going to use the law of cosines here. I'm going to call this angle C. So this is equal to lowercase c. I'll call this one angle B, angle A. So this will be lowercase a, and this will be lowercase b, just like that. All right, so C is 4 radical 3. So we have 4 radical 3 squared is equal to a squared, which is 4 squared, b squared, which is 8 squared, minus 2 times a times b, which is 8. 8. Let me redraw that actually. I tried to get away with it, but want to build a good habit of being clean with it. And C is what we're looking for, because once we find the angle C, we can figure out what x is, because I can just say x is equal to 180 degrees minus C, right? Because C plus x create a straight line, and a straight line creates a 180 degree angle. So 4 radical 3 squared, that's 16 times 3, which is 48. 16 plus 64 is 80 minus 2 times 4 times 8, that'll be minus 64, cosine of C. So let's go ahead and subtract 80 from both sides. That gives us a negative 32. And I'll be dividing by that negative 64 to get cosine of C. Now, this is 1/2. In order to solve for C, I'm going to use inverse trigonometry or inverse cosine. And that's how we know C is going to equal 60 degrees. So if C is equal to 60 degrees, that means x has to equal 180 degrees minus 60 degrees. So x is equal to 120. But if you noticed, I said this diagram is not drawn to scale, and it's actually a right triangle. Because if we have 4 radical 3 here and 4 times 2 is 8, and 4 times a radical 3 is 4 radical 3, and we know this as a 30, 60, 90 triangle. So that's how we know right away this is 60 degrees. Therefore, this angle right here has to be 120. That would have been the shortcut. And that's it. If you enjoyed this or learned something new, make sure to subscribe and check out the description below for links to my courses. See y'all soon.